Okay, so far you have seen solving systems of a quadratic and linear system or quadratic systems by graphing and substitution. Here we're going to look at example of solving them by elimination. So the first thing you want to do is you want to look at your system and you want to eliminate one of the variables. Now, first thing you want to do is you want to look and try to eliminate your y variable. That is the one that is just a single variable, 1 to the 0 term. So that's always the one you're going to want to eliminate. Now, this system is nice and set up for us. We've got minus y on top and plus y on bottom. If the coefficients of these were different, you would want to just go ahead and multiply them so we get opposite signs and same coefficients. Remember how we did this in one of the previous chapters. So the concept's the same as we did in that chapter. Once they have the same coefficient and opposite signs, you just want to go ahead and line them up and do the addition. So in this case, when we add our two equations together, we're going to get 2x squared plus x squared gives us 3x squared, minus 5x plus 2x gives us minus 3x. Obviously our y's cancel out, and then we get negative 2 plus 0, so we have minus 2. Now we're going to have to go ahead and solve this quadratic some way so that we get our solutions for x. What we want to do is we want to put this in standard form, which means we have to add both sides by 2 to get our right-hand side equal to 0. So we get 3x squared minus 3x plus 2. Now, once you get here, you want to use one of the methods that you've learned to solve for x. Remember, we've got graphing, we've got completing the square, we've got factoring, we've got using the square root, and we've also got the quadratic formula. In this case, we see that completing the square would give us a bunch of fractions. This does not look like something that would be easy factorable. What we probably want to do on this is use the quadratic formula. There's no other reason to use one of the others, and these numbers are not too large and would make it pretty straightforward to use that. Now, in this one, we look and see that our a value is equal to 3, b is negative 3, and c is 2. So we're going to get negative b, which gives us minus negative 3, so we get positive 3, plus or minus, we get b squared, which is 9, minus 4 times 3 times 2. So 4 times 3 is 12, times 2 is 24. So we get 9 minus 24, so we get minus 15 under our radical sign. That whole thing is over 2 times a, so 2 times 3. Now, the important thing to note right here is that we get negative 15 under our radical sign. If you remember, because we have a negative value under our square root, this quadratic here has no real solutions. This never crosses our x-axis, so we actually have no real solutions. Here, we are going to get some solutions that have I in them, which means there are no real roots. So what that means is that our original system also has no real solution. If we wanted to go ahead and check this by graphing, this is what our two graphs would look like. What you find is two parabolas that never actually cross each other. So again, remember, the fact that our quadratic we got by adding our two quadratics together, because we got an imaginary solution for that, it means that our system has no real solutions. This is what we get by graphing it. If you want to check that in Desmos, you can go ahead and check that to confirm that it does not work. So again, now this applies to substitution or graphing as well. If you use substitution and you got an imaginary result, what that would mean is that you have no real solutions to your system. And just writing that down as an answer is perfectly fine. No real solution.